Tina slowly, slowly. We be working all day long, the push us bunny. We ain't playing no games, Sabatavi, Gani.
Okay guys, question number 3. So question number 3, we are given cos alpha plus 1 equals to 3 sine squared alpha. I promised you guys that we are going to continue with this question. So can you see that, guys? We have cos alpha plus 1 equals to 3 sine squared alpha. We cannot change sine. We can't change sine. I mean cos, but we can change sine squared to be in terms of cos. So we are going to drop this cos alpha. Then say plus 1 equals to 3. We know that, guys, a sine squared from your square identity is 1 minus a cos squared alpha. Then we close the brackets. So we drop this one again. It's cos alpha plus 1. So then we say 3 times 1, and then we get what? 3. 3 times negative 1 here, it's going to get negative 3 cos squared alpha. So we transpose these to that side. So if I transpose negative cos squared to this side, the sign is going to change to become positive. So it's going to be positive cos squared alpha plus cos alpha plus 1. Then these 3, guys, the sign is going to change to become minus 3 equals to, don't forget your equal sign, 0. We have nothing here. Now we're gonna drop this one, 3 cos squared alpha plus cos alpha. So 1 minus 3, we get negative 2. Then it's a matter of factorizing now, good people. You can let cos to be x, okay? So if you are comfortable by making x as your variable holder, so I'm gonna factorize this one, guys. So the factors of 3 is going to be 3 cos alpha. The factors of 2, guys, is 2 and 1, but I cannot put 2 here because 3 times 2 we're gonna get 6. So it's more like this, guys. You did factorization on grade 10. So its factors of 3 is 3 and a 1. The factors of 2, let's say, is 2 and a 1. If I say 3 times 2, I get 6. If I say 1 times 1, I get 1. If I add these numbers or subtract, I don't get 1. So I have to swipe here 1 and 2. So if we swipe, I'm having 1 and 1 and 2 and 1. If I say 3 times 1 is 3. If I say 1 times 2 is 2. If I subtract or add these numbers, we will get 1 if we subtract. So I'm going to have this one as your factors. So this is your 2 and this is your 1. This one will become positive. This one will be negative. So in this case, guys, we have 3 cos alpha plus 2 equals to 0, or cos alpha minus 1 is equals to 0. So if you transpose 2 to that side, I'm going to have 3 cos alpha minus 2. What do you need to do next? Then you divide by 3. Then you get your cos alpha is equal to negative 2 over 3. Understand? So here, guys, it's easy now. We can get your reference angle, but you must consider the sign here. The sign is negative. You need to go where cos is negative. So I'm going to say reference angle is equal to inverse of cos, which is 2 over 3 plus k to 360 degrees, where k is the element of integers. So what do you get? Arc cos 2 divided by 3, we get 4819 degrees plus k to 360, where k is the element of integers. Then we are done with this the reference. We need to go where cos is negative. We know that, guys, cos is positive on the 4th quadrant and the 1st. So I need to go to the quadrant 2 and the quadrant 3. So I'm going to go to quadrant 2. Then I'm going to say, remember, this is very important, guys. I'm going to say 180 minus my reference angle plus the period. So I'm going to say alpha is equal to 180 minus our reference angle. This is your reference angle guys, this is your reference angle, this one. So I'm going to subtract 48,19. So this is 48,19 plus your periods, 360 degrees, where k is the element of integers. So what do we get if we say 180 minus this one? We get 131.81 degrees, 181 degrees, plus k to 360 degrees, where k is the element of integers. Then we need to go again to quadrant number 3, because cos is also negative there, guys. I'm going to have alpha is equal to 180 degrees plus my reference angle, which is 48,19 degrees, plus my periods, which is 360 degrees, where k is the element of integer. So what do we get if we say 180 plus 100 plus 48,19? We get 228,19 degrees plus k to 360 degrees, where k is the element of integers. So we are done with this one, guys. We need to find solutions using this one again. But this one, guys, we don't have the numerical value here. I need to transpose 1 to that side first. So I'm going to have cos alpha is equal to positive 1. Then we see that this numerical value is positive, guys. So I'm going to have two solutions. So if I'm going to have two solutions, I'm going to say cos alpha is equal to 1. Then I get my reference angle first. Inverse of cos 1 plus your period, 360 degrees, where k is the element of integers. So inverse of cos 1, guys, is 90, if I'm not mistaken. Oh, it's 0, sorry. So it's inverse of sine, that is 90. So it's 0 plus k to 360 degrees, where k is the element of integers. So where do we find cos and positive, guys? We find cos on which quadrant? Fourth quadrant. So I'll go to fourth quadrant. So I'm going to alpha is equal to 360 degrees minus your reference angle. In this case, your reference angle is what? It's 0. So it's going to be 0 plus your period to 360 degrees, where k is the element of integer, so which is the same as 360 degrees. So then we are done with this equation. Then we can see the next question, guys, that we have here. So the next question that we have is this one, guys. So I'm going to start with number 2, followed by number 3. Then we are going to do number 1, the last one, because this number 1 is the same with this previous question we just did, guys. So I just want us to do number 1, number 2, and number 3. Then we do number 1, the last one. The only thing that is new here to you guys, these are your intervals. So if we start with number 2, guys. So number 2, we are given root 2 sine x minus root 2 cos x is equals to 1. So I need to solve for x again here. So you need to ask yourself, guys, what must you do now? If I square both sides, it won't help me. But whatever I do on my left side, I must also do it on my right hand side. But I can see this is square root of 2, square root of 2. We know square root of 2 comes whenever we are introducing your special angles. So if I divide throughout by 2, so same thing, guys. If I take this one, this is square root of 2 over 2 sine x minus square root of 2 over 2 cos x 1 over 2. Can you see that if I multiply by 2, I can take this thing back to the previous original question if I multiply by 2 throughout? But we notice something here, guys, special. Square root of this one, guys, is equals to sine 45 or cos 45. So this one is equals to cos 45 sine 45. So these guys, what do we need to do? I see this is sine, this is cos. We know that, guys, sine 45 is equal to square root of 2. Cos 45 still is equal to square root of 2. So if I change this one to become cos 45, then I have sine 45. Understand? Then here we have minus. Sorry, we have minus. I just want to be the compound angle of sine. So I have cos 45 now is going to be sine 45 cos x equals to 1 over 2. Now, guys, I'm going to swipe this thing to be sine x cos 45, because the compound angle of sine, start by saying sine cos. This thing, guys, is the same with this one. Minus, what do we have? Cos x sine 45 equals to 1 over 2. Now, do you consider, guys, here, do you recognize compound pattern here, compound angle pattern? So this is going to be A, and this is your B, this is your A, this is your B. So if this is expanded, guys, so I'm going to reduce, so it's going to be sine x minus 45. Remember, sine, guys, keeps the sign. Understand? So equals to 1 over 2. So we're going to do the inverse of sine here to get the reference angle. So we see that the numerical value is positive, plus k to 360 degrees, where k is the element of integers. So what do we get, guys? It's 30 degrees plus k to 360, where k is the element of integers. Understand? So, guys, bear in mind that this is not your solution, this is your reference angle. But on this side, guys, remember our angle was x minus 45. So now I'm going to say this is x here minus 45. Then I transpose 45 to that side. I'm going to have a 75 degrees plus k to 360 degrees, where k is the element of integers. Can you see that we said this numerical value is positive? Where do we find sine positive? Because we were dealing with sine. We find sine on which quadrant? Second quadrant. So quadrant 2, I'm going to say, I take my reference angle, which is x minus 45 is equals to 180 degrees minus this 30 plus k to 360 degrees, where k is the element of integers. Guys, I emphasize, you don't subtract this one. You subtract here 30 and use this one as your angle. So if I say at 180 minus, we get 150 degrees. So we have x minus 45 plus k to 360 degrees, where k is the element of integer. So therefore, your x, 150 plus 45, is 195 plus k to 360 degrees, where k is the element of integers. Understand? So these are your solution. Okay, guys, let's try to do it on the we see that there's no other way. So if, guys, you decided to say, okay, what if this is sine 45 and this is cos 45? Let's see what we'll get if we do it like that, in that way. So I decided now, okay, no, sir, I hear you, Mr. Chi, that you have a square root of 2 and sine x. So I'm going to take it here, guys, from this step. Minus square root of 2 over 2 cos x is equals to 1 over 2. I hear you, Mr. Chi. We know that cos 45 and the sine 45, they are co-functions. They are co-ratios. So if I decide to make this one sine and this one make this one and cos, because I see that you made this one to be cos and made this one to be sine, because you want to get the compound angle of sine. What if I want to get the compound angle of cos? Let's see what we are going to do. I'm going to say this is cos 45 Okay, if you say cos 45 is equals to sine 45. We know these are core ratios, guys. So we only have this option here. I'm going to change this one to be sine 45 times sine x minus cos 45 cos x. Right. Okay, let's manipulate, guys. We want to see if the solution will be the same now. So if the compound angle of cos, start by saying cos sine. So we have to take this one to this side. This is negative cos 45 degrees times cos x plus. We are not changing everything, guys. We just rearrange. So we don't need this negative, so I'm going to divide by negative 1. Negative 1. So I'm going to get cos 45 degrees times cos x. So positive divided by negative, you're going to get negative sine 45 sine x is equal to negative 1/2. Okay, so this is the compound angle now, guys, of cos. This is your A, this is your B, this is your A, this is your B. So it is expanded, so I'm going to reduce. So it's going to be cos. Remember, cos, guys, changes the sign. So it's going to be 45 degrees plus your x equals to negative 2. Now, guys, we have to consider the numerical value is now negative. You have to get your reference angle and go where cos is negative. So I'm going to say a reference angle is equal to inverse of cos 1/2 plus the period k to 360 degrees, where k is the element of integers. Understand? So inverse of cos half, guys, it's 60. But guys, bear in mind that on my left hand side I don't have x only. I have 45 degrees plus x. This is your angle, so we transpose 45 to that side. So I'm going to have x is equal to 60 minus 45 plus k to 360 degrees, where k is the element of integer. So if I say 60 minus 45, what do we get? If I say 60 minus 45, we get what? 15 degrees. Understand? So we change this one to become a cos, guys. We change this one to become cos. This angle, which is 45, change this one to become cos. And we change this one to become cos, so that we flip again. Then we have this 45, 15 degrees. So where do we go again? We go to the quadrant number 2. So if I go to quadrant number 2, I will say this is 45 plus x is equals to 180 degrees minus 60 plus the period k to 360 degrees, where k is the element of integer. So this is 45 plus x. So if I say this one, we're going to get 120, then plus k to 360 degrees, where k is the element of integers. Then we transpose 45 to that side. So I'm going to have x is equal to 120 minus 45. So 120 minus 45, then we get what? 75 degrees. So are we together? So now we get 75 degrees. So then we go on which quadrant? Quadrant 4. Quadrant 4, cos is positive, so we don't go there. We go to quadrant number 3. So quadrant number 3, we're going to have x is equals to 180 plus your reference angle. So your reference angle in this case is 60 plus k to 360 degrees, where k is the element of integers. But we don't have only x here. We have 45 plus x is equals to 180 plus 60. What do we get? 240. 180 plus 60. We get 240 degrees plus k to 360 degrees, where k is the element of integers. What do we need to do next, guys? We need to transpose 45 on which side to that side. So if I transpose 45 to that side, I'm going to have x as, so we say 240 minus 45 is 195 plus k is equal to 360 degrees, where k is the element of integers. I hope, guys, you can notice that we get the same answers. So this is for 195. When we're using sine, the compound angle of sine, we still get 195. We did get 75. Yeah, we still get a 75 again. Understand? So that's how you do it, guys. So let's see number 3. So number 3, guys, number 3, we have cos x plus square root of 3 times sine x equals to square root of 3. Whenever you are dealing with this thing, guys, there's nothing you can change here, but you can derive this equation into your compound angles, because we know that the coefficient here is 1. If I divide by 2 throughout here, because we know that all the special angles, their denominator is 2. If I divide by 2, so now we're gonna have half cos x plus square root of 3 over 2 sine x equals to square root of 3 over 2. Now we need to find the relationship between the cos and the sine of square root of 3 and the 1 over 2. You know that, guys, 1 over 2, sine 30 give us 1 over 2. But cos 30, what does cos 30 give us? Cos 30 give us square root of 2 over 1. Same applies. You can use, guys, listen to me. You can use sine 30 and a cos 30. If we try to use sine 60 give us root 3, and a cos 60 give us what? 1 over 2. You can use a sine 60 and a cos 60. It's up to you, guys. So I'm going to use sine. I'm going to choose the compound angle of sine. So I'm going to change this one to be sine 30 cos x plus cos 30 sine x is equal to square root of 3 over 2. You can change this one, guys, to be cos 60 and the sine 60. But this one must be sine 60 cos 60. So this is the compound angle, guys, of what? Of sine. So I'm going to have A and a B, and this is A and a B. So, guys, sine keeps the sine. So I'm going to have sine 30 degrees plus x equals to square root of 2, square root of 3 divided by 2. Then I have to find my reference angle. So I'm going to say reference angle is equal to inverse of sine square root of 3 over 2 plus, can you see this one, guys, is square root of 3 over 2 times k to 360 degrees, where k is the element of integers. So here, what do we have? Square root of 3 over 2, we get what? 60. Remember, guys, on this side, we are not having just x. We have 30 plus x. 30 plus x plus k to 360 degrees, where k is the element of integers. If we transpose 30 to this side, guys, it's going to affect this value only. It's not going to affect your period. Your period is being affected only if you divide. So I'm going to have my x here as 30 degrees plus a k to 360 degrees, where k is the element of integer, because 60 minus 30, you're going to get 30. So where do we find, guys, sine positive? We find sine positive on which quadrant? Quadrant 2 only. So I'm going to go to quadrant 2. Quadrant 2, guys, say its theta is equal to 180 minus your reference angle. So I'm going to say 30 plus x is equal to 180 degrees minus my reference angle. So in this case, my reference angle is 60 minus 60 plus k to 360, where k is the element of integers. So 30 plus 108 minus 60, you're gonna get 120 plus k to 360 degrees, where k is the element of integer. So therefore, you're gonna transpose this 30 to that side, guys. If you say 120 minus 30, that's 90, plus k to 360 degrees, where k is the element of integer. So these are your solutions for number 3. Understand? So guys, we're gonna do this one, the last one, the ones that he contains the intervals. So guys, when you are dealing with the intervals, to find the solution in a given interval, you have to find the general solution first, then substitute the k with integers, with integer value to generate a solution in the interval specified. So you are going to use the k. That's why you see that whenever we're dealing with the general solution, we say k times the period, guys. So we're gonna do this one, guys. I hope that it won't take us a long time. Okay, so let's do this one. So we have 1. This is cos 2x plus 5 cos x minus 2. So same procedure, guys, same procedure. So I have to change this one to be in terms of cos, because we cannot change this cos, guys. Don't think of your square identity now, because you don't have sine here. But if you were having cosine, cos times sine, you are going to introduce your square identity. So which one I need to take here? So I'm going to take number 2. So number 2, we have 2 cos squared x minus 1 plus 5 cos x minus 2 equals to 0. So this one, we drop it down. So plus 5 cos alpha. So minus 1 minus 2, we're going to get what? Minus 3 equals to 0. So guys, it's a matter of factorizing now, guys. So we have to factorize. So if I factorize this thing, I'm going to have 2 cos alpha. So I'm going to put 3 on this side and a 1, because the factors of 3, it's 1 and 3. So I'm going to put plus here and minus here. So we know that, guys. What do we have here? I'm going to have 2 cos alpha minus 1 equals to 3. Equals to 0. Or cos alpha plus 3 is equal to 0. For this one, guys, we know that cos alpha will be equal to negative 3. There's no solution here. No solution. Why? Because we know that cos, guys, cos x, this is x, not alpha. Sorry, guys, I've been saying alpha. This is x. This is x. So cos x, guys, is greater or equal to negative 1 or less or equals to positive 1. This is my reason. That's why we don't have solution. We're going to focus with this one. So this is 2 cos alpha is equal to 1. Then I divide both sides by what? By 2. So your cos alpha is equal to 1 over 2. We find the reference angle, guys, here. So if we find the reference angle, guys, I'm going to say reference angle is equal to inverse of cos, which is 1 over 2 plus k to 360 degrees, where k is the element of integer. So what do we get here? We get 60, if I'm not mistaken. Inverse of cos 0,5, 60. So guys, you need to ask yourself, where do we find cos positive? We find cos positive on which quadrant? On second quadrant, on the first quadrant and the fourth quadrant. So quadrant number 4 is going to say this is Lx equals to 360 degrees minus my reference angle plus your k to 360 degrees, where k is the element of integers, so which is 300 degrees plus k to 360 degrees, where k is the element of integers. So guys, we said that since we are given here the restriction that the intervals that our solution must be between or equals to 0, between 0 and 360 degrees, So we're gonna generate, guys, using the integers. So what I normally do here, guys, I will say when cos, guys, when k, we are going to use k. This is your reference angle, guys. If I say when k, guys, equals, I will not choose the negative integers because my solution are positive, all are positive. So I'm gonna start with 0 when k is equal to 0, because integers, guys, we have negative integers and a positive integers. So it's like a number line, 0, 1, 2 up to positive infinity, -1, -2 up to negative infinity. That's your integers. So I'm going, when k is equal to 0, I'm start with this one, guys, with this one. So I'm going to have here x is equals to what? X is equals to 60 plus k. So in place of k, guys, now we're gonna substitute 0 times 360. What's the value that we get? We'll get 60. Understand? Or else we can use, let's say, okay, let's ignore this method. So let's try to do the table so that you can see. I think the table will be much easy. So okay, so then we have, I think the table is going to be much easier, guys. We have k here, then I'll say 0 because I have positive integers, 1, then I have 2. There's no need for me to go to number 3, but you can go to 3 as long as your solution will lie between these values. So my x, first x, 60. My second x here is what? X is equals to 300. So guys, I'm going to here, I will say 60 plus 0 times 360. What do we get? We get x is equal to 60 when k is equal to 0. Then you go and change here and put 1. When k now it's 1, you get 420. There's no need to move forward because this number is already above 360 degrees. We don't move, we go to 300, guys. We use this one now, this. So if we say 300 plus 0 when k is equal to 0 times 360 is 300. So then we put 1 is 610. So can you see, guys, we already exceeded 300 here. Hope you understand this table, guys. So these are not our solution. So this is your solution and this one is your solution. So how do you write it down, guys? How do you present it? So I'm going to show you how do you present it. So since you have these solutions, guys, so I'm going to say here x is the element from 60 degrees to 300 degrees only. So this is your solution. Okay, all right, guys, this was a long video. We are going to do more questions when we have the last questions or when we have the intervals. So thank you for watching. Please stay tuned. We are going to do more and explain more about this table. Some teachers, they don't use the table, but I'm going to do the table method. So guys, I hope you understand. Stay tuned for the next video. If you didn't subscribe, don't forget to subscribe. Thank you for watching. See you next.